In this lesson, we're going to look at what we mean by magnetic material, and to understand these, we're going to have a look at something called magnetic domains. So what do we mean by magnetic material? Well, these are materials which are attracted to magnets, or which can be used to make permanent magnets, for example. Now, as far as you're concerned, doing GCSE physics, there are only 3 elements on the periodic table which are classed as magnetic materials, or which can be used to make permanent magnets. And these are iron, cobalt and nickel. And they're situated together on the periodic table, so let's just make a note of this. So we've got iron, which is the most common magnetic material. Then we've got cobalt, and then thirdly nickel. Now they are magnetic materials because they are all ferromagnetic. And as you'll know, ferrous is the Latin for iron. And so iron was the first ferromagnetic material to be discovered. Well, cobalt and nickel are also referred to as ferromagnetic materials because they all possess the same property, which is called ferromagnetism. So in order to understand why these materials are ferromagnetic, why they are attracted to magnets and why they can be used to make magnets, we need to understand a little bit more about ferromagnetism. What is it? So we can think of each atom as being a little tiny magnet, and its magnetism is produced by the fact that electrons are continually orbiting and spinning around in the atom, and this produces what is known as a magnetic moment. You don't really need to worry about that, but it just means that each atom can be treated as a tiny little magnet. Now, when most of the elements in the periodic table come together to form solids, they do so in a random way, so that all of these little magnetic moments, as they're called, the orientations of these tiny little magnets, the atoms that make up the material, they all line up in a completely random, chaotic way. So the net result is that the total magnetism of the material is 0. Okay, but in 3 elements in the periodic table, which we've just mentioned, that's iron, cobalt and nickel, when the atoms line up, something called magnetic coupling takes place. When this happens, each atom causes the atom next to it to line up in such a way that its magnetic field is pointing in the same direction. So this lining up of the magnetic fields doesn't happen over the entire structure of the magnetic material, but it occurs over very small regions called magnetic domains. So what that means is you get, in our iron nail, if you look here, we've got very, very tiny crystal domains. In each crystal domain, all of the atoms are aligned in such a way that you get a very high magnetic field intensity, but the domains are only very, very small, typically less than 1/10 of a millimeter in length. So these domains go through the whole structure of the iron material. But the point is that although they have a very high field intensity, the resulting magnetic field produced by each domain is orientated in a different direction. So in our standard iron nail, the domains are orientated at random. So you may get one domain pointing that way, but in the next domain, the atoms line up so that the magnetic field points that way, then that way, then that way. So you get a completely random distribution of magnetic fields throughout the material, and as a result, the net magnetic field produced, for example, in our iron nail is 0. Now, just to finish, I'd just like to mention that to save me having to draw out all of these crystal boundaries, I shall represent the domains, for example, in an iron nail, such as this one, in this way. Okay, so each of these little red arrows represents the magnetic field produced by a domain. And you can see in this particular case that the domains are organized randomly. So the net magnetic field in this iron nail is 0. Now there are just a couple of things that I'd like to emphasize before we finish. And the first thing is that all this business about ferromagnetism and magnetic coupling and all this stuff to do with atoms really is outside of your GCSE curriculum. You don't really need to worry about these things. They're there just for a background because it's kind of important to know where this concept of domains comes from. But what is really important for you is you know these domains are there, and you can use them to explain a number of different phenomena associated with electromagnetism and with magnets, and these phenomena we're going to look at in the next few lessons, including, for example, why iron, cobalt, nickel are magnetic. We've just looked at that. How to make a magnetic material like iron, for example in the case of an iron nail, become a magnet. Let's say how to magnetize it, and then how to demagnetize it, how to remove its magnetism. The question of how, for example, commercial permanent magnets are made, we'll look at that, and what we mean by magnetic induction. That's to say how an iron nail, which is a magnetic material but not necessarily a magnet, is attracted to a permanent magnet. To really explain all of these phenomena, we will be using the concept of magnetic domains. So magnetic domains are really important.